Hello and welcome to Cracking the Cryptic and an intriguing looking puzzle today. Can't wait to get on with that. Happy Easter to you if you're celebrating the major Christian festival of the spring. And yeah, have a great time. Don't eat too many eggs. Now, in terms of what's going on the channel, we've got now Simon's Fistamafel Solve on Patreon, along with 3 days left to enter 3 times a Sudoku. You will still have time to complete it all if you haven't had a go at it yet. If you haven't even joined Patreon, you could still get that done, solve that puzzle, get an entry in, have a chance of a prize. So it's all possible there on Patreon. Obviously, there's all our apps on the links under the video, and Sven's Sudoku Pad and Discord, etc., etc., etc. Now, this puzzle is called Orbital Sandwiches 3. Dusara wrote to us and said that a couple of years ago, I think, they came up with this rule set, which they now realise was quite complicated for a rule set, and the puzzle didn't really make it worthwhile understanding the rule set. But this time, after a couple more goes, they think they've got it, so that the puzzle teaches you about the rule set and uses it. So, okay, interesting. Looking forward to this. Now, when I read the rule set, I didn't really understand it, but then I looked at the grid, and with the grid in sight, it does make sense to me quite clearly. So, normal Sudoku rules apply. Small circles, those are the ones with the numbers in, are planets inside a sandwich, which is a strange mixture of metaphors. Now, a sandwich consists of a sum of digits enclosed by 2 buns, both a crown, which is a 9, and a heel, 1. Each planet's sandwich is set along an orbital path around the central square, and the number on the planet gives you its inner sum of digits. Digits may repeat within a sandwich, excluding the sandwich's 2 buns. Now, let me explain what this means. So, in between, well, each number, look at this 22 on the right here. That comes in between a 1 and a 9 in this outer white orbit. Somewhere to its north is a 1 or a 9. Somewhere to its south around here perhaps is a 1 or a 9. And the numbers sandwiched between add up to 22, which is a bit like sandwich Sudoku. Now, in terms of the bread metaphors, I'm not too worried about buns and crowns and heels. I may end up just calling 9s and 1s crusts, as we have done in our in our sandwich metaphor usage in the past. But the point is that obviously the clues in this grey orbit apply within that. The 16 is sandwiched, well, clearly between that 9 and a 1 that's either somewhere up here or this 1. And that 1 is 1 crust around a sandwich that is 6 and has a 9 somewhere down here. So that's how it must work. Okay, I understand the rule set. And I'm going to have a go at this. Do try it on the link below the video. I think once you've just got your head around what that means, it should be very, well, I don't know, it should be very manageable, but let's have a go. I'm going to start now. Let's get cracking. So this 6 is the smallest planetary clue. And that means that there are 6 sandwiched either as a 2-4 pair or a single 6. Has to be under the 1 because of where the 6 is. And then 9 must come in one of those 2 cells. And I'm sure, as usual with a sandwichy type Sudoku, identifying the crusts is going to be the interesting thing here. Now, this 30, well, it's got to be at least 4 cells. So 8, 7, 6, and 5 are the most these 4 cells could be, and they only add up to 26. So this cell is going to come into the sandwich, and that is the heel, the other crust. And this number, if those can only maximally add up to 26, this one's at least 4. Yeah, and this whole, I might as well colour. That whole sandwich of 30 is the green cells. Now, 14, can that be similarly those 5 cells? I don't think it can. I don't think it can because 2, 3, 4, 5, which is the minimum values for these cells, already adds up to 14. Now, what does that mean? That means that the 9 is going to come sooner than that 9, and it can't come here or here because they would clash by Sudoku rules. So I think the 9 has to come here. These numbers have to be 6 and 8. They have to be the whole of the 14 sandwich. And that clue is done, effectively. So these are just not clued between a pair of 9s. Fair enough. Now, this time, this is different. This could come to the 1, because 2, 3, 4, 5 is 14, and a 2 there would make 16. That's possible. Actually, it must be that, because this time, you can't have a 1 here or here again. If you put a 1 there, these two would have to add up to 16, but they wouldn't be allowed to use a 9, so you can't do that. So this time, it's the opposite case. Those are all in the sandwich. That is 2, 3, 4, 5. This is a 2. And now that sandwich will work. And we've done the 16 clue. And we've done the 14 clue. This 30... that can't be 6 or 8 now. No, even better. On the 6 clue, it can't be 2 and 4 because we've got a 2 in the column. So we can fill in a 6 and a 9 crust. And that one is done. Might as well colour it. But I think all the sandwiches in this orbit, no, well, not this green one, but the others are done. Now, what's in the green one? No, actually, what's in this cell? It's naked, isn't it? 2, 3, 4, 5 in the row, 9, 6, 8, 1 in the column. That has to be a 7. And that's brilliant. That takes a 7 out of that cell. Now, there's not a lot of scope here. 4 was the minimum value, which made that maximum 26, 8765. So if that's a 4, this is 8765. If that's a 5, this is 8764. And look, 768 are there. So that's 876. This is a 4-5 pair. And that must be right. So we have done that sandwich now. The other cells in column 2 are a 2 and a 3. This can't be 2, 1, 6, 9 or 7, 8. So it's 3, 4 or 5. 9 in the top rows in one of those cells. Now, we've got lots of clues in this 4th orbit. Oh, sorry, this out. I don't know what I mean by 4th. I do, actually. It's the outside. If that's the 1st orbit, that's the 2nd, that's the 3rd, that's the 4th. I don't know how my brain came up with that without me actually consciously thinking what I was talking about. Maybe that's normal. Now, I've been planning to think about this 8 for ages. I haven't really got very far with it. Okay, where's its 9? It can't be this far away because 8 can only be... Well, it can only be a maximum of 2 cells, so the 9 is either there or there. If the 9's there, the 1's here, that's either a 2-6 or a 3-5 pair. If the 9's there, then you could have 8-1, or this could be a 2-6 or 3-5 pair, so I don't really know enough about that. Maybe think about this 17 clue then, which has got a 9... The trouble is this might not be where its 9 is. Because the 9 could be on this... Actually, no. The 9 for the 17 clue can't be on this side. Because those 9s mean none of these cells can be a 9. So that's far too many cells to make up 17. So the 9 is on this side. So the 1 is on this side somewhere. Now, could it be this far away? No, because the 9 would have to be there, and that's 5 cells. And the least 5 cells can be in a sandwich is 20, 2, 3, 4, 5, 6. So the 1's not there. So the 1 is in one of these 3 cells. The 9 is in one of those 2. 17 has to be at least a 3-cell sandwich. So it could be those 3 cells. It could be those 4 or those 3. I think those are all possible. I don't quite know how I'm meant to figure that one out. Right, what about this 22? Where's its 1 or 9? I don't know much about that. That's surprising. I really don't. It doesn't have a 1 or a 9 in this box because they're done already. Down here, there's no restrictions. Up here, there's very few. I suppose those can't be 1s, but there could be a 1 in one of those 2 cells. Okay, I don't really know what to do there. Now, let's think about this again. The 9 for this 8 was in one of those positions. The 1 must be fairly close as well. It can't be this far away. So the 1 is somewhere within that span. Yeah, but that doesn't really help. Now, the 34, 34 is not a regular sandwich clue. Ah, that matters actually. 34 can't be a sandwich clue in an ordinary sandwich Sudoku because the numbers 2 to 8 add up to 35. And you can't take one of those out and leave 34. Now what that means in this puzzle is that there is a repeat digit within the 34, so it must go round a corner. Either that corner and get to that 2 or 3, this corner and get to that 2 or 3. It can't go very far around the corner. So if it goes round, that means, I'll tell you what that means. That means that on one side of this 34 in the column, 9 and 1 must appear on the same side of it. Why am I saying that? Because there is a sandwich that goes round the corner, and the sandwich doesn't have 9 or 1 on it. So it's either there, and then 9 and 1 are up here, which would have to be a 9 here, and a 1 in one of those 2 cells, and then the sandwich would come round here somewhere. Or it's those cells, and maybe some more at the top, and then 9 and 1 would be down here. Trouble is, I'm not sure that helps. I mean, I know that this sandwich goes round a corner, but I don't know which corner. I don't know how far it goes. If you had, how many cells could it be? If it went 2, 3, 4, 5 there, that's only 14. And then you could have 3 more cells along here. So you'd put a 9 there and a 1 there, and it would all work. Oh, I haven't looked at this first orbit, this middle box. So 9 is in one of those 2 cells. I don't think 9 can be in this big sun in the middle. I'm going to call it a sun because everything's orbiting around it. I don't really know why it's been set with a big circle, but anyway. If 9 was in that, my point is this, if 9 was in that, how is this 22 ever going to have a 9 in its crust? The rules include that it must do, so the 9 can't be there. So that's 9. 1 is actually in one of those 2 positions. Again, 1 can't be in the middle for the same reason. Hang on. Is this possible? Those 5 could add up to 22, or these 5. Yes, it must work one of those ways. It obviously, wherever you put the 1, the short side is not going to be the sum. So it's the long side. So if you had a 1 there, the 22's on the path. If you have a 1 there, 22's on that path. Yeah, that's fine. Now, what does that mean? That means using the rule of 45, which is that every row, column, and box adds up to 45 in a Sudoku. The numbers in this box that don't get included in the 22 sum are the crusts, the 1 and the 9, and the central digit, which is not on the orbit, and the 1 digit in one of these top corners that is not there too. Now, 22 plus 1 and 9 is 32. That plus whichever corner it is adds up to 13 in 2 cells. I've just noticed that I can disambiguate this, not that way round, this way round, 6, 8 pair. And look, we've got 2 cells either there or there that add up to 13. Well, none of them can have a 6 in. So it must be a 5-8 pair. So the central sun is a 5. One of those is an 8. It's on the same side as the 1 because it's not included in the 22 sum, which is 2, 3, 4, 6, 7, which adds up to 22. So that's not a 5. I mean, I'm not sure I've advanced. I mean, I've got a couple more numbers in. 9, 9. One of these is a 9. Now, if it's here, what's happening with the 34 sum? It's going to come up here and come round here until it hits a 1. Sorry about my cold. It's very annoying. So what does that do? I don't know. Why should... If 9's not there... if 9's not there, then 9's here. Then 9's not here. Then this is the 9 for the... That would be interesting. That would make this the 9 for the 8 sum. You'd get a 1 here. That would push the 8 1 over this side. Wouldn't necessarily give you a 1 at the top there because it could have a 1 here and a 1 there. Oh, there's some sort of chain to be done here, but maybe there's something better. I've got to think about this now. Or maybe I have not done enough Sudoku. Yeah, for instance, this cell can't be 6, 7, 8, 9 or 4, 5. So that's 1, 2 or 3. Now up here, we've got a 1, 6 and 8. I should have done this before. This might matter. Now, if that was a 1, I think that would be nonsense. This might matter a lot. If this was a 1 up here... no, I was going to say the 22 couldn't possibly work. Because you couldn't get round to this for a 9. But you don't have to, do you? The 9 could be here. And actually, that 1 could be there without even being a crust of the 22. It could have a 9. No, it couldn't. None of these can be 9. So if that was a 1, then you'd be meeting 9 here or here. You'd have 22 in the middle. I don't think it could be a 9 here. Because for those to add up to 22, that would have to add up to 13. That's on its own. That's not possible. So if that's a 1, that's a 9. These add up to 22. But that is very possible. Now the alternative is that one of these is a 1. Then that's not a 1. Then this 17 is getting encased in either... Well, then this is a 9, because that couldn't be. If that can't be a 1, then this can't be a 9, because the sum here is 3 or 4 cells. Sorry, 3 or 4 cells. So that would have to be the 9. Now that wasn't possible in the case where that's a 1. Because the 9 was going to have to be here. So you couldn't have a 9 there. Now what I think the trouble is, I may have just been looking at 2 totally different circumstances. I was trying to imagine a 1 in one of those cells, so that... Let's start with there being a 1 in one of these. Then that is a 9. But is it a crust for the 22? It could be, or it might not be, because there could be a 1 in one of those. I don't know how this works. Sorry. Okay, think about 2. There's a 2 there. There's definitely a 2 in one of these 2 cells. So there is a 2 up here. It could well be there, but it doesn't have to be. I'm getting a bit bogged down here. I'm just getting stuck in thinking about these various orbiting possibilities. I think I've largely dealt with this orbit entirely. I think I've dealt with this one. You know, once I put in the 1, I can put in the 8, and we're finished. So the clues I have left are just in the outer orbit. But which is the one I'm meant to think about? I don't know. Is it this 8? This 8 is quite appealing. Now, could it be a single cell 8? If it was, that would be the 9, that would be 8, that would be 1. That would be how that would have to work. Then this would be 8, because it couldn't be in those 2 cells anymore. Doesn't really get much done. You'd have 8, 1 here, 6, 7, 9. Don't know. So it could be a single cell 8. Otherwise, it's a 2 cell 8, either in those positions or in those positions. If it's in those positions, that's a 1, which fixes a 1 there, which didn't get me anything. Oh, good grief, I just don't know. Okay, let's go back to thinking about the 34. So this could have a 9 here. In that case, 1 must be down here somewhere. These 4 are in the sandwich. The sandwich is going to run into a 1 somewhere there. Now the most they can be up here is 8, 6, 5 and a 7 there. That's 30 already. That doesn't get us far enough. 33 maximum. So the sandwich would have to come at least here. Now that would, so if that was a 9, that would push the 1s into these cells, and that pushes 9 over here. So now these 2 cells both have to be 9s. If that's a 9, that's a 9. But I don't know where 9s go in the bottom row. I think they'd form an X-wing around those cells, or in the bottom 3 rows, I mean. The 17? Oh, okay. If that's a 9 and that's a 9, then the 17 forms a sandwich here, and then there's a 1. I don't know which of those cells are in. Let's say it's that one. But you've got a total of 17, and 9 and 1 is 27. The others are 18, and that's in the 34 sandwich. Then the rest there would have to add up to 16 to make the 34 sum. That's quite possible, infuriatingly. Oh, there must be one of these 9s that I could just falsify just by thinking about it and just make it not true so that I could move on. Why can't I tell which one it is? I'm just not thinking far enough down the right course, I think. So I need to step back, have a little thought about that. There's obviously an 8 in one of those 2 cells. Don't see how spotting little Sudoku things at this point is really going to help, but you never know. Oh, come on. If this is a 2 cell clue, it uses either a 2 or a 3, as does that cell. Then the ones outside the sandwich would always have to be from 4, 5, 6, 7, or 8. That's not very helpful either. Can I rule out a 9 from here? The 22 sum would have to be at least 4 cells, would have to go in those. It couldn't probably be as long as 6 cells. Oh, that would have to be a 1. These can't be a 1 because of the position of 1 in the top row. So if there was a 9 here, they would add up to 22. That would be a 1. I don't know. I don't know what it means. Oh, dear, sorry, you've got me going here. I'm struggling, as you can see now. 1, 2, 3, 4, 5 are the possibilities in those cells. It doesn't matter if that's a 1 because the orbiting sums here and here have been done. Maybe I need to think about these. If 8, 1 are over that side, then these are from 2, 3, 4, and 7, and the same the other way around. If that's 8, 1, these are from 2, 3, 4, or 7. They can't have a 6. Oh, I don't know. I'm going to think about the 34 again. I'm going to go back and think about the 34. That's the one that's most appealing. Partly because of the repeated digit thing, the fact that it must be quite big. There must be a lot of cells in it. There must be at least 7 cells in it. So if that was a 9, none of these would all be in the sandwich because they couldn't be 9 or 1. But there must be a 1 and a 9 in column 1, obviously. So 1 crust is somewhere in it. I mean, that's just a fatuous thing to say. Oh, right. Imagine that's a 1. How about that? Imagine that is the 1 that is the crust of this 34. Then we have to go around here. And I think it wasn't enough to be just those cells. Didn't we work that out? 8, 7, 6, 5 here is 30 plus 3, 33. That's not enough. So if that was a 1, that can't be 9. This can't be 9. So the 9 would have to be down here. You couldn't go that far or you've just got too many. So that would be the 9. So if that would be the 1, you've got 2 or 3 there, then this group adds up to 32 or 31. Then you get a 9 and a 1, definitely still to come in the column. And that's 41 or 42, and then you get a 2 or a 3. So you'd have a 9 here. This would be part of a 1, 2, 3 triple. This would be a 6, 7, 8 triple, and that would have to be a 1, which counters the original proposition that this is a 1. So this is not the 1 in the 34 sandwich. This cell here. Okay, that is slightly complicated. I'm going to go through it again, partly to reassure myself. So, if this is the 1 in the 34 sandwich, that's not enough because it can only add up to 33. So that couldn't be a 9. We know that can't be a 9 because of that. The 9 would have to be here. These would have to add up to 32 or 31. There's still a 9 and a 1 to come. 42 or 41. And that's where yeah, okay, that's all right. It would have to be 42. This can't be a 4 because there's a 4-5 pair. So that would have to be, I think, a 3 and a 1 with a 2 there. This would become a 6, 7, 8 triple. That would make that a 1, and that's impossible. So this, okay, all I've proved there at some length is that this 1 is not the 1 in the 34 sandwich. Ah, Well, the 9 in the 34 sandwich is not in the top row. So have I nearly proved that the one doesn't go round, that this sandwich doesn't go round the top? No, I haven't, because this can be the 9. I think I've proved this can't be the 9 in the 34 sandwich. But this could be. As long as we go round a bit further up here. And then one of these is a 1, then that's going to be a 9. Okay, that's possible. So if the sandwich goes round the top, we've got a 9 there and a 9 there. If the 34 sandwich goes round the top. I think that is definite. Because it must meet a 1 before a 9 in the top row. That's right. Okay. Now, that would be useful to know that there were 9s in those positions, but I don't know that. I just know that if it goes round the top, there are 9s in these orange positions and a 1 in one of those two. Now, if it goes round the bottom, we can't have a 9 or 1 there. Where is the 9 in the sandwich? It can't be in any of those cells. They can't be a 9. So the 9 must be below and the 1 must be above. So the 1 would have to be in one of those two cells. If this sandwich goes around the bottom, it can't go around both corners. So the 1 would be in one of those two cells. The 9 would have to come fairly soon, because the minimum rather, these can add up to 2, 3, 4, 5, 6, 7 is 27. So you can't carry on to meet a 9 here. So that would be the 9. Right. So either this 34 sandwich goes around the top and that's a 9, or it goes around the bottom and that's a 9. And in either case, this is not a 9 because it sees one of those two cells. I think that's good enough. So that's not a 9. Now by Sudoku, you've got those two 9s. If that's not a 9, that is a 9. And now we do know how this 34 sandwich works. It goes around the top. That's a 9. In fact, this is not a 1. That's the important finding there. One of these two is a 1. Come on, keep going. We've got a 9 here. That's not a 9. There's a 9 in one of these two cells and a 9 in one of these two. That X-wing that I was talking about has come to pass down the bottom. It hasn't told me anything about how this 8, right, but this 17, we've got a 1 in one of those two. We've either got 17 in 3 cells here, which could be 872, 863, 854, 764. Lots of possibilities if that's a 1. If there's a 1 there, then the 17's in 4 cells. But there's quite a lot of possibilities for that. However, they can't include 2 and 3. So 2, 4, 5, 6. That's what it would have to be. This isn't going to work. Okay, I'm imagining a 1 here and this 17 sum. Now the really important point about that is the 17 sum, if it doesn't have 2 and 3 in it, then the minimum numbers, and it doesn't because of this cell, then the minimum numbers that would be involved are 2, 4, 5, 6. That adds up to 17. If you put 2, 4, 5, 6 there with a 9, 1 either side, this would be 3, 8, 7, but that clashes with that 7. So it's not a 4-cell sum. That's not a 1. This is a 1. These 3 do add up to 17. There are quite a number of ways they can do that. But we got a 1 here. Now that means this isn't a 1. And that means this 8 isn't a 1-cell sum, because 9 is out in one of these cells and 1 is either, I imagine it's either there or there. Yeah, if you can't have a 3-cell sum, I think if 9's there, 1's got to be there. If 9's there, 1's got to be there. Yeah, so there is a 1 in one of those two cells. That might be useful down here. Or not. And we've definitely got a 2-cell 8 sum. So we're using 2 and 6 with 3 there, or 3 and 5 with 2 there. Now, okay, this 34, can we do that? Now we know it's 7 cells. I doubt that we can, because there seems to be... okay, we can do this sum across the top. 17 plus 10 is 27. Those are 18. These 3 add up to 16. Now, I don't even think I can rule out 1 from here. I'm just going to colour them to try and remember that the red cells add up to 16. Let's make them blue for contrast. The blue cells add up to 16. These add up to 18. These add up to 17. Oh, what about the 22? I don't know, because they... Right, the 1 is in one of those positions, the 9's in one of those. It doesn't really tell me about 9 and 1 in this column. Where is 1 in this column? It's not there, and it's not here. I don't think it's going to be in either of those 2 cells. If that was a 1, this lot would add up to, what is it, 35, and all be in the sum. That's not a 1. Okay, so 1 is now definitely in one of these 2 cells. Now, if that was a 1, 17, 18, these either add up to 27 or 25, and they're all in the sum. So that's not a 1 either. 1's also not in those cells. So now 1 is in one of these 3 cells. That's not a 1. And since that's not a 1 and that's not a 1, the 1 in column 7 is there. Now, one of these, right, now surely, yeah, the 22 is bound between the 1 in its column and the 9 in its column. So, and it includes this cell. So it's either these 4 adding to 22. Can it be these 5? If it was all 5, oh, it's got to be those 5. That we can't have a 1 there. It can't be more than 5 because 6 cells would add up to 2, 3, 4, 5, 6, 7 would add up to 27. Yeah, so the 1 is here. Oh, now we're getting somewhere. So that's not a 1. The 1 in this row is at the beginning. Might have finished my 1s now. That's a 1. That's not. These add up to 22. Plus 9 and 1 is 32. These 2 add up to 13. That's got to be 5 and 8. Oh, this is happening now. That's fixed 4 and 5. These can't be 5 or 4, so they're 3 and 2. Okay, this is a 9-6 pair now. This is a 4-7 pair. So at the top of this column I have 5-8. That has to be a 6. That fits with this final column. Can't have 5s in those cells. Right, this can't be 8, so the 8 in this row is there. 5 in box 6 is there. 2, 3, 4, 7 plus 6, that does equal 22. Okay. 3, 4, 7 still to go in that column. Now, these add up to 17. So these 2 add up to 9. Oh, that's... Okay, this can't be a 2 because I seem to have pencil marked 2 up there. Yes, because of 2 and 2, that's right. So this is 5 or 6. This is not 7. So 7 in the row has to be there. This is either 2, 3, 6 or 2, 5, 4. I thought I'd be flowing by this stage. Not. Right, we knew this was a 2-cell sum, so it's not a surprise to get an 8 there. I still don't know. I mean, I thought this 8 sum would be one of the first to fall, and it couldn't be more opposite to that. Still haven't sorted out this 9 X-wing. I've done the 22 clue. Let's colour these again. So let's make them blue, that 22 clue. 2, 3, 4, 7, and that one, and 6. 17 clue is up there. We'll make them red. Let's get rid of those orange 9s, which were just because that was some marking to do with one cell replicating the other. 7, 7 That's a 7. So that's a 7. So this is a 2, 3, 4, triple, to be resolved. I'm probably being very slow. That's become an 8. Now, these had to add up to 16, but that's from memory. I just want to check the maths at the top. 17, 27, those are 18, yes. 16 here, take away 8. These two add up to 8. They are either 2 or 3 there and 5 or 6 there. So the 4 in the column is in one of those positions. Gosh, it's not getting any easier. That 5 or 6 must be the same as that. Doesn't really do anything. Come on, we're getting there now, though. I'm feeling good about the puzzle in general. I'm just not feeling that I'm tackling it brilliantly. I'm going to blame being a bit ill. 1, 5, 4, 9 in one of those cells. Oh, come on, think about it. Maybe this middle box. Oh, 7 can't be there. If I knew that was an 8, I could put in 8 and 1 here. Then I could put in a 1 here. That would be really helpful. Two and 3 are a pair. 1 there and 1 in the 8 sum, which is somewhere in here. Now that means this can't be anything from 1, 9, 2, 3, or 8, or 4, 5. So that's 6 or 7. It's done nothing, has it? 1, 4, 5, 9, 8, 2, 3, 6 or 7. Now, if that was also 6 or 7, we'd have a pair. We'd have a 5, 3 pair. And we'd need 2 and 4 in the rest of the column. Oh, Mark, come on. 2, 3, 6 or 2, 5, 4. So 2 and 5 or 6 are used between those. So this is 3 or 4. I get no clues in this orbit. That's 2, 3 or 4 just by Sudoku. Five, 4, 1. Oh, this is tricky, tricky, tricky. I mean, I'm not going to bifurcate, but I'd be tempted to in other situations, just down at the bottom here. We either put 1 and 9 in there, then if this was, let's imagine that's 1, 9, then you could put 2, 6 in there, 3, 7, 4. Ah, where does 5 go in the bottom row? It's in one of these 3 cells. It's in one of those 2. That's a 1, 5 pair. Now, if that's a 1, that's 5 and that's 3. If that's a 1, that's 9 and that's 5 and that's 3. So 5 is always in the sandwich with a 3 there. Is that going to help me or is it not? I've got a 1, 5, 3. Yes, that makes this a 2. That's a 3. That fixes this as a 4. That's now a 5. 3 there. Oh, goodness, that's been waiting for ages. Right, this is a 2, 6 pair. So that's a 5. This is now a 4. This added up to 16. So that's a 3. That's not a 3. We get a 4 in the column. That's not 4. The top one's not 3. Still haven't resolved the 8 one. Still haven't resolved this. I know it's made up of 3, 5 now, but I don't know which way round it goes. 2, 4, 5, that's not a 2. We have got a 6, 7 pair, so that's a 2. That's a 6. This isn't 4. In fact, 2, 5, 7 to go in this triple. Oh, so that must be a 2. Yes. 2, 7, 5. This is now an 8. I think we're getting there now. 9 in the bottom row. So that's fixed my X-wing of 9s. It must be 9, 5, 3, 1. There we go. 7 and 6. 7 and 4. That 1 has fixed the central orbit. Wow, this has taken some doing. And been a great deal of fun in the process, I have to say. Right, 2, 4 pair there. So that's a 3. That fixes column 9. 2, 7, 6 there. So this is a 4. That fixes 2 and 4 in the green. Let's just highlight the rest of the orbits before I forget. There's another one. 8, 22, 17 and 34. And this 22 in the middle is that group, just so we know. Okay, that's all the orbits done. 2, 4 and 8 here. I can do them. 8, 2, 4. 6 and 7 there. Must be able to do this 2, 6, 7 triple. And the final triple at the top. Oh, I'm pleased to have got through that. I do apologize for the suffering nose, but there we go. That is the solution to Orbital Sandwiches 3 by Dusara, and a very entertaining puzzle it was too. Probably not quite as difficult as the video length this time, I suspect. Although every step I found pretty tough, I have to say. Most entertaining. Thank you so much to Dusara for sending it, and thank you for watching as always on the channel. Bye for now.